In this video, we're going to look at example 4, where we add and subtract radical expressions. So something that is important before we even get into this is the phrase like radicals. It's similar to like terms. There's some rules to it. So like radicals have to have the same index and the same radicand, which is the number inside, in case you forgot. So the only way we can and this applies to addition and subtraction. So like radicals have to have the same index and the same radicand. Multiplication, division, you can multiply or divide radicals. You'll have to do more work, and there's rules there, but this is for addition and subtraction. So what that tells me in example 4 is that this radical 20 and this negative radical 5 can be put together, and then these two cube roots can be put together. All right, but I won't be able to combine the radical 20 and the cube root of 16. All right, they're not like radicals because they have different indexes. Now, let's start by rewriting this as radical 20 minus radical 5 minus the cube root of 16 plus the cube root of 250. All right, so what I'm doing here is I'm just rearranging the terms, right? We're allowed to do that in addition and subtraction as long as we keep the signs. There won't be any issues. Nothing here has the same radicand. All right. However, the radical 20, we might know ways to break this up. So radical 20 can be rewritten as radical 4 times 5. So we're looking for perfect squares that go into 20. A factor of 20, that's a perfect square, would be 4. So we would subtract this radical 5. And then these cube roots, we want to do the same thing. All right. Are there any cube roots of 16? Any perfect cubes that are factors of 16? Well, there are. All right, 2 times 8, 8 being a perfect cube. And then cube root of 250. We're looking for, again, a cube root of 250. Our cube roots, we have 1, you have 2 cubed, which is 8. We just used that one in the previous part. 3 cubed is 64. Oh, sorry, 3 cubed is not 64. I'm getting ahead of myself. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. And I see that 125 does go into 250. So I'm going to make this 125 times 2. I'm actually just going to switch these two. I'm going to write it as 8 times 2, not 2 times 8. All right, so we can keep moving forward with this. The reason we're doing this is we're trying to get the same radicand so that we can either add or subtract. So the square root of 4 times 5, that would become the 2 times radical 5 minus radical 5. 8 times 2, that would be minus the cube, minus 2 times the cube root of 2, right? Because the cube root of 8 was 2, we can bring that outside, plus the cube root of 125 would be 5, and then we'd have the cube root of 2. And now those two radicands are the same, and those two are the same. So we can then move forward with this. The 2 radical 5 minus radical 5, think of this as a 1 here. Think of this as 2x minus x. That's 2x minus 1x. So what I can do is I do 2 minus 1, which is just 1. The radicand stays the same, the actual radical itself. So we don't do 5 minus 5. Again, this is very similar to 2x minus 1x, where that would just become 1x. We don't change anything about the x value. And the 1 really doesn't need to be there. Next part, be careful. This is a negative 2. So we have negative 2 plus 5. That would be a positive 3. And then the cube root of 2 stays the same. We're not going to change anything about that. I'm just going to rewrite this without the 1 in front of it because we don't need that 1 there. And then this would be our final sum. We can't do anything with those two because, again, we can't add unlike radicals. And they both have a different index and a different radicand. So that would be it for that one. These ones, I think students tend to favor a little bit more compared to other parts of this section. You just have to make sure that you're grouping things together based on their index, and then you're going to have to simplify something's on the inside to to try and get them to have the same radicand. If they don't have the same radicand, you can add them up. Right? Even if you had something like, uh, you know, radical 5 plus radical 3. All right, they do have the same index, but the numbers on the inside are different, and there's nothing we can do about simplifying radical 5 or radical 3. So those two would just have to remain separate. The try-it problems will give you some good practice, and then go from there.